This is a video about the Edison Slough Tide Gate located in Skagit County. It is also about the potential for vandalism at self-regulating tide gates. First, a little background. The initial attempt to install a tide gate that allows backflow at Edison Slough involved the installation of a self-regulating tide gate produced by Waterman Industries, which was installed in 1998. The Waterman gate had problems and was very controversial with the surrounding agricultural community. It was eventually replaced with a side-hinged self-regulated tide gate fabricated by Golden Harvest that was installed in 2005-2006. The Golden Harvest Tide Gate, which they sell under the name GH850, is an obvious copy of a tide gate that I designed back in 1994. The Golden Harvest Gate never worked right at Edison Slough. From what I've been told, it was completely closed nearly all of the time. The GH850 at Edison Slough had an extreme case of what I call tide gate entropy death. For a detailed description of tide gate entropy death, see my website at www.jeweltide.com under the Q&A tab. While pondering tide gate entropy death and how to prevent it, I came up with a revolutionary idea for a fish-friendly tide gate. In August of 2008, I gave Skagit County a price for fixing the Edison Slough Tide Gate and told them that if it didn't work, they didn't have to pay me. In January of 2009, I disconnected the hydraulic cylinder and installed my improved control mechanism. My new control mechanism works great at this site and in fact will work at virtually any site. The retrofitted gate opens wide on every falling tide when the water levels are equal. It allows limited backflow on the rising tide, and it closes reliably when the water level in the slough upstream reaches the desired water level, plus or minus about 4 inches. The mechanism is simple to disable during extreme events. By disabling the mechanism, the gate becomes a regular flap gate, thereby maximizing the drainage capacity. While I was promoting my new tide gate design, in the span of less than 3 months, 2 people independently suggested that my new tide gate control mechanism could be subject to vandalism. Having a new operating control mechanism alongside the disconnected hydraulic system at Edison Slough provides a wonderful opportunity to compare the two designs and assess the potential for vandalism. The tension regulator of my new control mechanism is located inside this steel tube and it is completely inaccessible to vandals. The mechanism for adjusting the tension is accessed by removing a tamper-resistant screw, which requires a special bit. The only exposed and vulnerable component is the light gauge wire rope. With some work, a determined miscreant could cut it using a hacksaw or cable cutters. Stainless steel wire rope is readily available and the replacement cost would be less than $20. The time required to replace the severed wire rope is less than an hour. While awaiting repairs, the tide gate would be a free swinging flap gate and it would not result in flooding. Compare this to the potential vandalism that could be inflicted on the now superfluous hydraulic components of the Golden Harvest 850 tide gate. That same vandal and his hacksaw, with minimal effort, could sever one or both hydraulic lines, spilling hydraulic fluid into the slough. A vandal could also saw into the case of the hydraulic cylinder or mar the rod. It would be no problem to open the control cabinet and tamper with or destroy hundreds of dollars worth of hydraulic components. A clever miscreant could also figure out a way to jam the float in the float well of the GH850. This would cause the hydraulic cylinder to hold the gate open regardless of the water level. The Golden Harvest control mechanism could be vandalized in ways that make a huge mess or cause potential flooding, take days or weeks to repair, and cost thousands of dollars. With my improved control mechanism, there is no way that the mechanism can be vandalized in a way that would result in flooding. Any damage that could be done could be easily repaired, quickly, and with minimal expense. There is no hydraulic fluid involved in my improved design. The tension regulator probably will need to be replaced at some interval. My supplier won't make a commitment as to how long it will last, but 10 years is not a stretch, and they could last indefinitely. The replacement cost is less than $50 and it takes less than an hour to replace the tension regulator. As of February 2008, there are 4 side-hinged tide gates that have been retrofitted with my patent-pending control mechanism. They are all working great.